Hello guys, I am Gautam. Welcome to Easy. Today I am going to discuss about some important points of Heisenberg uncertainty principle that you need to know. So let's start. So first, what is Heisenberg uncertainty principle? Heisenberg uncertainty principle says it is impossible to determine the exact position and momentum of a subatomic particle simultaneously, and the math form is for x-axis delta px delta x is greater than or equal to h by 4 pi. Here delta px equals to uncertainty or error in momentum in the direction of x-axis, and delta x is equal to uncertainty or error in position on x-axis, and similar case for the y and z-axis. What does this equation mean? This equation says if we measure momentum of a particle in any axis accurately, then some error or uncertainty must be present in the measurement of position of that particle, and also vice versa. Let's take an example. Say uncertainty or error in momentum, that is delta px, is equal to 10 grams semi per second. If I ask what is the error or uncertainty in the position of that particle, that is delta x equals to what? Then delta px delta x is greater than equal to h by 4 pi, and if we put the value of delta px, that is 10 grams semi per second, then we get delta x equals to 5.27 into 10 to the power minus 29 centimeter. This is a very small value. That means the uncertainty or error of the position of the particle on the x-axis is very small. This is because of high error in the momentum, that is 10 grams semi per second. That is, more error in momentum causes less error in position, and less error in position causes more error in momentum. Here you should know that Heisenberg uncertainty principle is not applicable for the macro system. Now you can question me that are only position and momentum variables obey Heisenberg uncertainty principle? And the answer is no. You can verify that whether any two variables obey Heisenberg uncertainty principle or not by the help of commutation rules. So what is commutation rule? Say two operator a cap and b cap, they will commute if a cap b cap minus b cap a cap equals to 0. It is also represented by, in a third bracket, a cap comma b cap. That is, a cap comma b cap equals to a cap b cap minus b cap a cap. The condition of applicability of Heisenberg uncertainty principle is that the two operator must be non-commutative. That is, a cap b cap minus b cap a cap is not equals to 0. This should be the condition. That is, if two operators do not commute, then their corresponding observable quantities do not have simultaneously well-defined values and thus obey Heisenberg uncertainty principle. So, for example, say x cap and px cap operator, and they operate on a function fx, so called f. So from commutation rule, putting the value of fx, we get the commutator value of the function fx, and which is I h by 2 pi fx. Ignoring fx, we get the value is I h by 2 pi, which is not equal to 0. That means we can say that px cap and x cap is non-commutative, and thus the Heisenberg uncertainty principle is satisfied by the px cap and x cap. You can also check whether these operators obey Heisenberg uncertainty principle or not. First, time and position; second, momentum and energy; third, kinetic energy and total energy. So these are the functions, and these pairs, every pairs can obey or not the Heisenberg uncertainty principle. Let's keep them as your homework and let's carry on. Now I want to say, if you have any topic to understand such as operator, function, observables, commutation, commutator, etc., then comment below and I will make videos on that topic you want, and also ask your questions about the topic. So now, how we verify the Heisenberg uncertainty principle? By the experiment. An experiment called gamma ray microscopic experiment helps us to understand the reality of Heisenberg uncertainty principle. The PDF file you will get in the description box, and you can easily understand the experiment. If no, comment below. I will make another video for this experiment. Next, what is the application of Heisenberg uncertainty principle? From Heisenberg uncertainty principle, we can prove that electron cannot be exist in nucleus. We can calculate the fast Bohr radii of the hydrogen atom from Heisenberg uncertainty principle, which is 0.53 Armstrong. We can also calculate the ground state energy of hydrogen atom from Heisenberg uncertainty principle, and also calculate the ground state energy of a harmonic oscillator from Heisenberg uncertainty principle, and finally the bandwidth of a spectra from Heisenberg uncertainty principle. All these calculations you will get as an easily understandable PDF file in the description box. So this is all about the Heisenberg uncertainty principle, and subscribe my channel to get more interesting videos like this, and stay tuned with Easy Chemics. Thank you guys. Jai Hind.